Okay, so I had a question on number 12 from the group quiz, so I wanted to go over that one. That one's the taco truck problem. You're sitting on a beach and all of a sudden you want a taco. You know that the taco truck is 500 feet away and you could just walk straight across the sand, but you walk slower across the sand and you walk faster across the boardwalk. So your two kind of extreme options are one, just hightail it straight through the sand, but only walking at 3 feet per second, or walk straight to the boardwalk and then walk along the boardwalk, which is a little bit faster, which would be a longer route, but since you walk faster on the boardwalk, who knows, it may be faster. Um, Being who you are, you decide not to take your path until you calculate the optimal route to get your taco. So, what a third option is you could walk some of the way, you could kind of angle it. You could walk some of the way on the sand to a point on the boardwalk, and then you could walk the rest of the way on the boardwalk. And so, the way I set this up was to create a function that models the time that you're going to take, regardless of what path you choose. Okay. So in that function, I need to have a variable and one variable. And that one variable I'm calling x, which is pretty uninteresting. And what x represents is the distance between the point I would get to if I walked straight to the boardwalk and the taco truck itself. And so since I know that this is a right triangle and two of my sides are 300 and 500, the missing side is going to be 400. So I'm going to call this 400 minus x. So now if I think of what's the path that I choose, it's going to be this hypotenuse of a right triangle that I have, and then a length of 400 minus x. So if I'm thinking of my function, I'm going to call it time as a function of x. I'm going to have to look at this triangle right here. And I know that it's a right triangle. I know that the missing side is going to be, it's going to be a squared plus b squared, and then the square root of that whole thing. So that one distance that I'm missing is the square root of x squared plus 300 squared. And if you think of what I want to know the time that it takes to walk across that sand. So if it were, let's say it were 12 feet and I walk at 3 feet per second, how long would it take? It would take me 4 seconds. If it were 100 feet and I walk at, if it were, let's say 300 feet and I walk at 3 feet per second, it would take me 100 feet per second. Okay, what I'm doing is I'm taking the distance and I'm dividing it by the rate, the speed that I'm going at. So I want x squared plus 300 squared divided by 3. And then the other distance is already kind of calculated as 400 minus x. And I want to divide that by the rate that I walk on the boardwalk, which is 8. Okay, and so now I can look at this as a function and pick from a variety of different paths and choose the one that's the optimal path. And I'm going to use Desmos. You could have used your graphing calculator, or you could have used Desmos on this. But let's see, 300 squared plus x squared divided by 3 equals, nope, plus, and it's not on the charts, it's off the charts. So I'm going to zoom out and I'm going to see. The nice thing about Desmos is that you just kind of get near it and it'll tell you what your minimum point is. So this is my minimum point here. And then with any kind of word problem, you're not done just when you get your minimum point. There still is a little bit of interpreting. What does this mean? Well, what is x? X is this value right here. X is that value, so that's going to be 121.356. But the question says, how long does it take you to get to the taco truck? Okay, so that's asking you for the amount of time which conveniently is the y value. So time equals 142.7. And what is it measured in? It's measured in seconds. Or I think this is 2 minutes and 22 seconds. And then the other problem some people asked about was just number 4, and it was specifically the domain. People were able to find the inverse, but then they were confused as to what the domain would be. So this isn't something that we've gone over quite a lot, but it is not okay in math to divide a number by 0. So we have to figure out what numbers would we get that would be not okay. What numbers would give me a 0 in the denominator? And so in the original function, I get x cannot equal -9. In the inverse function, well, let's see, I have to do this real quick. So for my inverse function, I get -5 minus 9x over x minus 2. And in the inverse function, x cannot equal 2, because that's going to give me a 0 in the inverse function. So if I think of how do I write that in interval notation, it'd be -infinity all the way to -9. Let's see, I'm going to write it somewhere where I have a little bit more space. -infinity all the way to -9. And then it would go from -9 all the way to 2. And then it would go from 2 all the way to infinity. And with the parentheses, it means it doesn't include those points. So if I were writing this on a number line, here's -9, here's 2. It would be like all these numbers here, and it would have a hole there. You'd have a hole there, and it would be all those numbers. All right, thanks for listening. Hopefully that was helpful.